In this video, we're going to look at the use of some of the trigonometric identities for integration. It's not an exhaustive list, but perhaps the more common ones are being used here. And I might also just add one while I remember, because I will be using this one later on. So the one I'm going to add is sine squared x is equal to 1 minus cos squared x. Okay, now we have here the letter k in each of these examples here is a constant, it's just a number. Now cos 2kx, k is a number, is equal to 2 cos squared kx minus 1, and that's equal to 1 minus 2 sine squared kx. Of course, sine squared x equals 1 minus cos squared x. Cos squared kx is equal to half in parentheses 1 plus cos 2kx, and sine squared kx is equal to half in parentheses 1 minus cos 2kx. We also have sine 2x is 2 times sine x cos x, and sine 2kx is 2 sine kx times cos kx. Okay, remembering of course k is just a number, a constant. So let's have a look at our first example. Sine squared 3x. Sine squared of 3x integrated with respect to x will give us the integral using this relation here, sine squared kx, where k is 3. Will give us a half. 1 minus cos 2 times 3 is 6x. So we'll have a half minus a half cos 6x integrated with respect to x. There's also should be a plus c here. I'll save that till the end. And that gives us the antiderivative of a half is x on 2. The antiderivative of cos 6x is 1 on 6 sine 6x, but there's also a factor of a half there, so that becomes 1 on 12 sine 6x plus the constant of integration. Another example is cos to the power of 4 of x, cos x to the power of 4 integrated with respect to x. We could write that as cos squared x all squared, and then where cos squared x, we could resort to one of the examples, like for instance this in the first one in the second line here on the left, cos squared kx, k is 1 in this case, would give us a half outside of 1 plus cos 2x. Okay, which is what we have, all squared dx. Now what we can do is expand that out, so that gives us a half squared is a quarter, 2 times the half cos 2x will give us a half cos 2x, plus 1 quarter cos squared 2x. Again, resorting to more identities from above, the integral of a quarter plus a half cos 2x, plus out here, this cos squared 2x, where k is 2, we're resorting to this one again, where k is 2, we can write that out as being 1 on 8, parentheses 1 plus cos 4x, the 1 on 8 coming from the factor of a half up here, multiplied by the quarter here to give us 1 on 8, outside of 1 plus cos 4x, here k is 2 here. Okay, there we go. So we're just about there. So that's the integral of a quarter plus a half cos 2x plus 1 on 8 plus 1 on 8 cos 4x. And the antiderivative of a quarter is x on 4. The antiderivative of cos 2x is sine 2x times 1 on 2. There's already a factor of a half there, so that gives us 1 on 4. Antiderivative of 1 on 8 is x on 8. Antiderivative of cos 4x is sine 4x multiplied by 1 on 4, but there's a 1 on 8 there, so that gives us 1 on 32 plus the constant of integration. Now, we can tidy it up a bit. X on 4 plus x on 8 will give us 3x on 8 plus 1 on 32 sine 4x. We've got 1 on 4 here and 1 on 32, and when we combine them, we're going to have, different things, my apologies. We're going to have 1 on 4 sine 2x here, 1 on 32 sine 4x here. The 2x and the 4x obviously are different, plus c, the constant. All right, next bit, another example. Let's have a look at the integral of cos x to the power of 4 times sine x to the power of 3, integrated with respect to x. So cos to the power of 4 of x. The sine cubed x will break down to sine squared x because we can use an identity on it. That's the extra one I added in red up the top, times sine x. Okay, so let's go there. Next line down, cos x to the power of 4 times 1 minus cos squared x. Okay, the sine squared x has been replaced by 1 minus cos squared x. That's the one I put in red at the start of the video, times the sine x. Okay, when we do that, we end up with cos x to the power of 4 minus cos x to the power of 6 times, expanding out the parentheses, across the parentheses, sorry, times sine x dx. Okay, might be ripe for substitution. Let's have a look. Let u equals cos x. Du dx is minus sine x. Okay, du is minus sine x dx, which is close to this n bit up here. It just differs by the minus sign, but that's all right. We can add in an extra minus sign to remove it. So we get the integral cos x to the power of 4 minus cos x to the power of 6 times sine x dx is minus the integral u to the power of 4, because cos x is u, minus u to the power of 6 du. And the minus out front here will cancel with the du, with the minus that's buried in the du, because remember du is minus sine x. And that will bring us back to the original expression we had. Now these are easy to anti-differentiate, because u to the power of 4 becomes u to the power of 5 on 5, minus u to the power of 7 on 7, plus a constant of integration. Then we just substitute back in and multiply through by the minus 1, which just reverses the order. It puts the u to the power of 7 in the front, u to the power of 5 second. And so we have cos x to the power of 7 on 7, minus cos x to the power of 5 on 5, plus a constant of integration. Next one, another one involving substitution. Okay, let's say we have the integral of 3 tan squared of 3x times sec squared of 3x dx. And we use one of the very first trigonometric identities up the top. U equals tan 3x. Du dx is 3 sec squared 3x. Okay. 3 sec squared 3x. Okay. And what we end up with is du is 3 sec squared 3x dx. Okay. And the integral 3 tan squared of 3x times sec squared of 3x, okay, is u squared. That 3 out front ended up being absorbed in the du. So we didn't need to put another 3 here, so we get u squared du, okay, because we're just substituting in tan 3x, squaring it to get us tan squared 3x. The rest is du. That's a very simple thing to integrate now. To anti-differentiate becomes u to the power of 3 on 3 plus a constant of integration, and replacing that with tan cubed 3x on 3 plus c. Okay, that bit there. Just one more handy rule that can help in these sorts of situations. N times the integral of cos x to the power of n dx becomes sine x times cos x to the power of n minus 1 plus n minus 1 times the integral of cos n minus 2 of x. That's cos x to the power of n minus 2. Now this rule can be applied more than once. It can be applied repeatedly until you break down all the integrands. So it's a very handy rule, and that's n times the integral of cos x to the power of n dx can be broken down in this way. Very, very handy rule. All right, that's it.